All right, so I had a couple quick questions on the probability practice quizzes, and so I wanted to make a little clip to help out with those. Yeah, we'll see. We'll see if this helps, and if you have follow-up questions, please don't hesitate to send them my way. All right, so the two questions were on the mask, the race, the mask one, and then the race one, the running one with the teachers. So the first one was the mask that I'm going to go over. And the mask problem says, Jacob walks into a store and is interested in 14 masks that are discounted because he's a student at Granada. How many ways can he choose 5 masks? So for this problem, we need to tell if it's a permutation or a combination. And remember, the difference between those is that in a permutation, switching up the order of items would count as an entirely new outcome. In a combination, if you switch the order, those collective things, in this case masks, would be seen as just the same purchase, and so it wouldn't really make a difference. And so in this case, you could say a combination. So the easiest way to tell the difference between them, I find, is that if I list out, let's say mask 1, 2, 3, 4, and 5. If I were to purchase those 5 masks out of the 14 and walk out of the store, what if I were to just switch? What if the cashier were to scan the masks in this order instead? The question becomes, would those be considered the same or different purchases? And when you think about it this way, you can tell, oh, well, I would still be walking out with the same 5 masks. It wouldn't really matter which order they were scanned in. So since in this case, I would say same, that means that this I could treat as a combination. So 14 combination 5, which would mean I could do 14 factorial over 5 factorial times 14 minus 5 would be 9 factorial. When I go ahead and simplify this out, I can just write 9 factorial here because that's going to cancel out with the 9 factorial on the bottom. Oops. There we go. Oops. Sorry, my hand keeps hitting the home button. There we go. And in this case, when I multiply all that out, I should get, let me just double check my arithmetic, 2,002 for that particular problem. Okay. Now this is going to be a little bit different than the race problem. The race problem was about if all 18 math teachers enter into a mile race, how many different ways can they finish first, second, and third place? So let's take Jeffries, Han, and myself as an example. Let's say we were to run this race and we were to finish Avila, Han, Jeffries. So that would mean that I got first place, Han gets second, and Jeffries gets third. So if I want to know whether or not switching up that order would make any difference to help me decide whether I should do a permutation or a combination, what if I just rewrite it in a different order and ask myself that question again? So if I switch Avila and Jeffries, now Jeffries would be in first place, Han would be in second place, and I would be in third place. Would those be considered different finishings? In this case, I can say yes, they would be considered different. So in this case, I could do 18. I could say permutation 3. That would have me do 18 factorial on top, 3 factorial on bottom. So basically, I would have 18 times 17 times 16 all the way down to times 4 with a 3 factorial on the end, which would cancel out with the 3 factorial on bottom. And that collectively would give me, 4896. So 4,896 ways that 18 math teachers could finish the race in first, second, and third place. All right, I hope that helps. Let me know again if you have any follow-up questions, and otherwise, I will hopefully see people at Zoom.